Hello Year 12. This is just a little short video in the alcohols chapter. Under the heading, as we can see here, comparing the energy produced in fuels. The idea behind this slide is, and the problem, is we want to be able to convert our enthalpy value, or the kilojoules per mole, into other units that are more user-friendly in society, that come up in some problems such as kilojoules per gram and kilojoules per litre and kilojoules per kilogram even. Yeah, so it's just a little bit of conversion that we need for here. So the table underneath is quite handy. It's showing some conversions. Enthalpy of combustions in the first one, then heat release per gram, kilojoules per gram, and kilojoules per litre. For the different alcohols, for some different alcohols is a better way to explain it. Methanol, ethanol, propan-1-ol, butan-1-ol, and pentan-1-ol. Okay, so these type of problems can come up in the HSC, and they're not too difficult. Yeah, let's look at a problem first. My biggest tip is you're just doing some conversions. So just use your units to cancel out. Okay, let's have a look. I'm blabbing on. Propan-1-ol has a heat of combustion of negative 2021 kilojoules per mole and a density of 0.803 grams per milliliter. Calculate both the heat released per gram and the heat released per litre. Okay, so the heat release per gram, we're going to look at, well, let's keep it all in kilojoules. So we're looking for the unit kilojoules per gram, the heat release per gram. What we do have is the kilojoules per mole. So we're going to multiply it by some fraction. We're going to get rid of the units that we don't want and introduce the units that we do want. Okay? That's a terrible line. Okay, we want to keep kilojoules at the top, so we're good, but we want to get rid of moles from the bottom because on the bottom on the left-hand side is grams. So mole up the top will lead to us being able to cancel once we figure out the unit. Okay, so that's a good start. What do we want on the bottom? We want grams on the bottom. And this helps us out because once we multiply these two values, we know we're going to be left with kilojoules per mole. Kilojoules per gram, because the moles are going to cancel out. So what we're saying is take our kilojoules per mole, and what are we doing? What's this multiplied by mole over grams? That's the inverse molar mass. So it's saying divided by grams per mole, or the molar mass of what you're looking at, and you're going to get it in the unit that you're looking for. So kilojoules per mole from the question divided by the molar mass of whatever we're talking about is going to get us the kilojoules per mole. I'm making so many mistakes. Kilojoules per gram. You're probably following a lot better than what I'm explaining. Okay, so kilojoules per mole is 2021 kilojoules per mole. And we're going to divide by the molar mass. What are we talking about? We're talking about propan-1-ol. Okay, it's based on propane, meth, eth, prop, so 3 carbons. So to be a saturated alkane, it's going to need 2n plus 2 hydrogens. 2n is 6 plus 2 is 8, and we're going to have an oxygen in there too. Okay, or if you want to do it by drawing it out, meth, eth, prop, put the 1-ol on there, and let's put the rest of the hydrogens in. It's always fun putting hydrogens in. Okay, so we've got 3, 5, 7, 8. Good, I got it right. Okay, so we're going to divide it by the molar mass, which is 3 times 12.01 plus 8 times 1.008, or not end of the bracket, silly duffer, plus the 16 of the oxygen, grams per mole. as usual. We've got lovely neat writing and setting out. That was sarcasm. So 2021 divided by my 3 times 12.01 and 8 times 1.008 and 16. I get 33.63, which sounds good for, yeah, I would have had 4 significant figures, so 33.63 kilojoules per gram. All right. Heat release per gram, tick. Heat release per litre, okay. Heat release per litre, kilojoules per litre is what we want. What have we got? Kilojoules per mole. And we want to get rid of the moles. And we can connect it. We don't know how many moles per milliliter, but we can connect it to the mass, okay? Just like we did in the earlier one. But now we've got to add on another thing, because look, we've got some units we want to get rid of. So we got rid of moles. Grams not on the bottom. So in the third fraction there, we're going to put grams up the top. And we've got, okay, we've got grams per milliliter from the question, 0.803 grams per milliliter. So we can put that in there. But you'll see the trouble is the grams are going to cancel and we're left with milliliters on the bottom. We want litres on the bottom. So we're going to multiply it by another fraction of milliliters per litre so that those cancel out. But this unit is a bit ridiculous because it's 1,000 milliliters per litre. So that's going to equal my 1. What have I got left? I've got my kilojoules per litre. Okay, so we're saying, by all my units cancelling out, is take the kilojoules per mole, divided by the molar mass, multiply it by, that's the unit of the density, multiply it by, 1,000. So that equals, well look, this, should I do it the cheaty way? Yeah, I'll do it the cheaty way. This bit there, I'm using a razor. This bit there is just the 33.63. And then I'm going to multiply it by the density, which is 0.803, and multiply it by 1,000. And that's going to get me my kilojoules per litre. Alright, 33.63, still in my calculator, that's handy. 0.803 times 1,000. And we want 4 sig figs, well, is 27,005.4 kilojoules per litre. But we want it to 4 sig figs, so let's call it 2.701 times 10 to the power of 4 kilojoules per litre. Hopefully I did good there. Let me know if I made an error. Alright, have we got another example? I think it goes like that. Alright, I think it goes like that. Terrible. So there's an example. It's just a matter of finding out what you need, using the units of what you've got and manipulating it. And I think there's a worksheet there. It's just those 2 questions to give it a go. Alright. Next, if you want some more examples, there's some from the textbook as well. Okay, just a short one. Thanks, guys.